Welcome everyone to this tutorial session. In today's tutorial, we are given the exponential equation x to the power 3 all over 2 equals 3 to the power 3 all over 2 to solve for x. How do we do that? Watch the solution that we have. We are going to present a simple, straightforward solution, and you are advised to watch from the beginning to the end. Okay, let's start. X to the power 3 all over 2 equals 3 to the power 3 all over 2. This index expression on the left hand side has the power 3 all over 2. This index expression on the right hand side has the power 3 all over 2. Now, the temptation here is to say that since the powers are equal, then we can equate the bases and end up by saying our solution is x equals 3. Well, this is just one of the solutions. We are actually supposed to have 3 solutions because this is a cubic equation. Look at the power at the numerator. The numerator is 3. The numerator is 3. It therefore means that this is a cubic equation. And all cubic equations must have 3 solutions. So how do we get the 3 solutions? Okay. The first thing to do is to move this 3 to the power 3 all over 2 from the right hand side to the left hand side. And so we'll end up with x to the 3 all over 2 equal, minus, this is positive 3 all over 2. When it's coming this way, it will be minus 3 to the 3 all over 2 equals 0. We now have 0 at the right hand side. Okay, to make it clear, to know that it is cubic equation, that's the power should be 3. We know that 3 all over 2 means power 3 all over 2 means square root raised to the power 3. Square root raised to the power 3. So we can now see clearly that it is a difference of 2 cubes. Root x cubed minus root 3 cubed. So we now use the difference of cubes identity to continue with our solution. Using that difference of cubes identity, we're going to have here root x minus root 3 into root x squared plus root 3 root x plus root 3 squared equals 0. So our equation is this. We have the product of 2 expressions giving us 0. Either this is 0 or the other expression is 0. So we say either root x minus root 3 is 0. If that is the case, then we are saying root x equals root 3. And if that is true, then it simply means x equals 3. This is our first solution. The first solution out of the 3. So how do we get the remaining 2 solutions? We also set this other expression equals 0 and solve. Now let's make space for that solution. So let's make space. We have now the other expression, which is root x squared plus root 3 root x plus root 3 squared equals 0 to solve. Now root x squared, the square will cancel the square root. We have x plus root 3 root x. Here also, the power 2 will cancel the square root. We have plus 3 equals 0. Now, this is actually a quadratic equation for those who can actually see, but we're going to make it clear. Now, x can be written as root x, all of that squared. Remember, root x simply means x to the power half. And then when we square it, it just gives us x. So we have just simply changed the form of x to this form. This expression is actually that. So we have plus root 3 into root x plus 3 is equal to 0. So we now see the quadratic equation in terms of root x. Let us make it even better by doing the substitution m for root x. When we make that substitution, we'll now write this quadratic in terms of m. Wherever we see root x, we put m. It now becomes m squared plus root 3 into m plus 3 is equal to 0. All right? The quadratic equation is a lot better now, better presented this way. Now, we can now solve this quadratic equation, which is in terms of m, by applying the quadratic formula. First of all, let us collect our coefficients. The coefficient of m squared, a is 1. The coefficient of mb is root 3. And the constant is 3. With this, we now apply the quadratic in terms of m, quadratic formula. It says m equals minus b plus or minus the root of b squared minus 4ac all over 2a. Let's put in the values of a, b, and c carefully. So we have negative root 3 plus or minus the root of root 3 squared minus 4 into 1 into 3. This gives us all of that divided by 2 into 1. This gives us negative root 3 plus or minus the root of root 3 squared is just going to give us 3 minus 4 times 1 times 3 is 12. All of that divided by 2. So this is the expression that will give us the values of m. Remember, m is root x. Okay, we continue this way. Let's continue this way. We have our two values of m given by that expression. So let's write it down again. M equals negative root 3 plus or minus 3 minus 12 is negative root 9 all over 2. Now, what is negative root 9? What is root negative 9? Root negative 9 is the same as root negative 1 times 9. This is the same as root negative 1 multiplied to root 9. We know that root negative 1 is the imaginary number I, and root 9 is 3. So this is just simply 3i. So we're going to replace root negative 9 with 3i in that expression. So we say m is equal to negative root 3 plus or minus 3i all over 2. Those are the two values of m. Pay attention, remember we're asked to solve for x and not m. So how do we bring in our x? The relation between m and x is m equals root x. So let's place this on the left hand side there and work out. So we have root x is equal to negative root 3 plus or minus 3i all over 2. To get our x, we have to remove the radical square root by taking the opposite operation of square root. The opposite operation of square root is squares. So we're going to square both sides of this expression. So let's write it there. When we square both sides, the square will cancel the square roots. And so we have x is equal to negative root 3 plus or minus 3i squared. Remember, the square will affect both the numerator and the denominator. So 2 squared is 4. Now, negative root 3 plus minus 3i squared. So we get the first value of x will be negative root 3 plus 3i squared all over 4. Now, what is negative root 3 plus 3i squared? Let's do it separately here. It will simply be negative root 3 plus 3i multiplied by itself. Negative root 3 plus 3i. Negative root 3 multiplied to negative root 3. Negative times negative positive. Root 3 times root 3, we have 3. Negative root 3 times 3i. So we're going to have negative root 3, 3i. The same thing here. 3i times negative root 3. We're still going to have negative root 3, 3i. And then 3i times 3i. 3i times 3i. Pay attention. We have I times I is negative 1. And 3 times 3 is 9. So our result is negative 9. So we have negative 9. Alright. So this will go for the numerator up there. Let's put it at the numerator up there. So we're going to have x1 is equal to 3 minus 9 is negative 6. So we have negative 6. Negative root 3, 3i. Negative root 3, 3i. There are two of them. Negative 2 root 3, 3i. All over 4. So that's our first value for x as this when using this quadratic formula. We see that 2 can divide all around. 2 here, 2 there, negative 3, and 2 here, negative 1. So we're going to have negative 3 minus root 3, 3i all over 2. This is the first value of x from this complex root. Now we get the second value of x. The second value, this is x1. x2 will be, we now take the negative. We take the negative, so it will be negative root 3 minus 3i all over 2. Remember, x is when we square both sides. So we square this, just like we did here. Okay? We squared it. So x2 is when we square this one now. How do we go on? The process is the same. The process is the same as for x1. The same thing we did for x1, we're going to do it here. So we have x2 is equal to negative root 3 minus 3i multiplied by itself, negative root 3 minus 3i all over 2 squared, which is 4. So negative root 3 times negative root 3, negative times negative, positive, root 3 times root 3 is 3. Negative root 3 times negative 3i, negative times negative, positive. So have root 3, 3i. The same thing here, positive root 3, 3i. Then now negative 3i times negative 3i. Let's do it down here. Negative 3i multiplied to negative 3i. Negative times negative, positive. I times I, negative. 3 times 3, 9. So this gives us negative 9. Okay, so we have negative 9 all over 4. So this gives us 3 minus 9, negative 6, plus negative, root 3, 3i plus root 3, 3i. There are two of them. So we have 2 root 3, 3i all over 4. Again, 2 can cancel all around. 2 there, negative 3. 2 here, 1. And 2 down there, 2. So this gives us our x2, the second solution for the quadratic equation. So we now have all our 3 solutions. Our 3 solutions, the first one is x equals 3. All right. The second one is x1, which is this. This is our second solution. Negative 3 minus root 3, 3i all over 2. And our third solution is negative 3 plus root 3, 3i all over 2.